Okay, students, can you all hear me? Can you hear me? Right, okay. Right. So, first of all, good evening for all of you students. Today is the first day of our paper class, term test target paper class. So, before we go for the paper session, before we start the discussion of the paper, first of all, raise your hand who got the tutorial. I sent you the tutorial. Raise your hand who got the tutorial. For the online students, I send the tutorial through post. For our physical students, I gave the tutorials to a hand. So please raise your hand who got the tutorials. Right. So many of you got the tutorials, right? Good. Right. Now, this is the thing. Students, before we go for the paper class, before we start the discussion, I want to remind you a few things. Listen to this one very carefully. I'm going to take 5-10 minutes to give you some important things. After that, we start the discussion. Okay. So listen to this one very carefully. Students, remember you are writing the A-level examination. You're facing for the A-level examination in 2026, right? So that means you have, if we assume that we have your examination in 2026 August, we have more than one, right? We have more than 1.5 years, right? So I told you before, this 2025 year is the most crucial year that you are facing in your A-level examination, right? So I started this paper class for the 25 batch also. That means for the previous batch, 25. For them also, currently we are doing the paper class very nicely, very well. So I sent you some feedbacks they gave. Your senior batch students, they gave some feedback. And I assume that I think that you have gone through what they have experienced in our paper class, right? So that means you have some kind of a recommendation or you have and some idea about our paper class, right? So the first thing is actually I want to describe about our paper class using 3 points, right? The first thing is actually what is the purpose? What is the intention of conducting this paper class? Remember, students, now we have completed unit number 1 theories. Unit number 2 almost finished, but we have to discuss a little bit theories in the online class. And unit number 3, I think we have done completely half of the theories that we have to discuss in the unit number 3. That means after the completion of unit number 1, 2, 3, any student should be prepared to do the papers, right? So our paper class is actually term test target paper class. So many students actually in your batch also requested me to do some papers. We have term test in January month. January we have term test. So therefore we feel like we are not prepared. So can we do some papers, right? So remember, students, every year actually we can hear this thing, right? Remember, soon after you learn a lot of theories, when you are given a paper, you don't know how to answer for a question, right? So writing answers for the question papers is a pattern, it is an art. You have to practice that, right? You have to do some papers. You have to continuously papers, right? So this paper class is somewhat a guidance to do papers. This is to encourage you to do the papers. Remember, many students are there. I know that you are not even don't know what is the paper structure, A-level paper structure, right? Because you don't think that this is so important. You feel like, right, learning theories are enough. It's not like that. And some of the students are there. Actually, they are doing papers by now. They have started already. They start, right? So I know some students. I know some students. They are giving papers weekly, and they are asking me to check the papers. So that's a very good move. Some of the students are there. So likewise, remember, students, doing papers is very important. So why we are conducting this paper class? What are the reason? What are the intention is to increase your term test marks. First of all, before we go for the A-level examination, first of all, you have to face term test examination school, right? I'm not talking about the private candidate, but those who are going for schools, you know that you have to face term test examinations. So you have to prepare for the term test. Because if you score a good mark in term test, so you have confidence, then I, I, I can do a paper. I know how to do a paper, right? If you can get more than 75 marks in the term test paper, so you have full confidence, right? That means all the theories I have learned, I correctly absorb them and I can do a paper. That confidence is very important. So you can increase, you can boost your confidence by doing this paper. That is the only reason we are conducting this term test target paper class. The first reason. And the next thing is how this is conducted, right? How this online paper class is conducted. So I have conducted 25 paper class for 1 year, right? So exactly before 1 year, I started for the 25 batch. So now currently they have in a good position, right? At the beginning, when we compared with the beginning, now they are in a good position. They can do a question, right? Our paper class is actually conducted through 3 phases, right? Phase number 1, phase number 2, and phase number 3. Listen to this one very carefully, students. Remember, in the phase number 1, I'm expecting you to attend for the paper class daily and do some papers and try to get an idea, try to get the experience of writing papers. ඒ කියන්නේ මේ phase එකේදී අපි කරන්නේ ඔයා paper writing එක කොහොමද කරන්නේ? How you are going to face a question, what kind of question patterns you will get. You have to know that one under the phase number 1. That means now, today onwards, we are starting this phase number 1. In the second phase is started actually at the end of this month. That means after 25 batch go for the examination in October. From November onwards, we are starting phase number 2. In that phase number 2, you will see that we have completed more than half of the syllabus. Then you can do lot of questions, lot of theories are there, lot of applications are there. So we are almost equal to the examination level in the phase number 2. That's what we are doing in the phase number 2. Now 2025 batch is actually in the phase number 2. right? We started that one from the last month, right? Because 24 batch went for the examination last month. They complete the examination. Now they are in phase number 2. You all 26 batch in phase number 1, right? So this is pending, right? We are starting this one in about, I think November we can start. They have announced 25 examination in I think October they have planned to keep the examination, right? So therefore we can start from November, we can start the phase number 2. And phase number 3. So this is very, very important. Under the phase number 3, actually we are going to do full papers. That means last 3 months before the examination. Anyhow, before last 3 months, we have completed the syllabus. Under the phase number 3, we can do full papers. So in phase number 3, actually, we are going to conduct 2 sessions. That means I'm taking the theory class time also. That means we are meeting 2 days per week. So in phase number 3, we are doing full papers and you will get the marking scheme also. So phase number 3 is directly what equal to the A-level examination papers. That's how we are conducting the phase number 3, last phase of the paper, right? And the next thing, sir, in online conducting a paper class is it possible? You may have a doubt like that. Yes. Remember, students, the only issue is actually we are not meeting physically. I can't watch you whether you are writing papers or not. But here, what I'm expecting you is your honesty, right? In the phase number 1, I'm not expecting you to write down the papers by keeping the time. But in this paper book also, I have given you those who are interested in writing papers by keeping time, you can try them. Otherwise, no issue, because in the phase number 1, still I'm going to take you into the track. I'm going to take you into the path, correct path. In here only, we are starting the correct way of doing the papers, right? Here we have to do the papers at home. ඔයා තනියම ගෙදර ඉඳගෙන papers කරන්න ඔයාට පුළුවන් ඒක. හරි මම ළඟට අවිලා බලන්න ඕනේ නැහැ physical පන්තිය වගේ ළඟට අවිලා බල බල ඉන්න ඕනේ නැහැ. What you have to do is you have to go for your studying table. So keep the stopwatch and do the papers by yourself. Because this is your life. So you have to be honest to yourself first of all. එතකොට ඔයා honest වෙලා papers ටික කරන්න. ඒකේ discussion එක අපි පන්තියේ කරමු. We are going to do the discussion in the class. Right? So in phase number 1, I'm not going to expect that one. Keep typing and everything. We just do the papers. We have the discussion. That's all. In the phase number 2, remember, you have to keep time at home. You have to write down the papers. Phase number 3 also like that. This is the way that we are conducting our paper class. And the next thing, along with the paper book, along with the question book, students, I have given you a review book, this kind of a book. With the black and white cover page, I have given you this kind of a answer and review book. In this answer and review book, I have given you that some blank pages. These are the actually papers that you will get in your examination. So you can familiar with these things by writing on these papers. You can get the idea about how to write down the answers on these papers. Try to manage the space. Okay, especially when you're writing essay papers. So you have to use this paper answer book, answer and review book to write down the answers. Not only the answers, review, right? What does mean by review? So this is something I didn't do for 25 batch, but for them also from the next paper book, now they have completed the 6 paper books. So from the next week onwards, they are starting 7 paper book number 7, right? Paper book number 7. So we have done so many questions, right? So remember students, so from the very first paper book, you are going to write down the review. Keep that in your this is very important, okay? Keep that in your mind. Writing review is very important. Mokad the review again. What does mean by a writing review? Students, remember, while doing papers, the advantage of doing papers is when you are doing papers, you can recall all the theories from the beginning. Now you see this paper, will you, the first MCQ paper? There are 25 MCQs. You can collect all the theories you learn from the unit number 1 up to now. Unit number 1 to unit number 3. Right? So that's what the advantage of doing papers. You can recall all the memory. So all the memory that you recall, right? All the theories that you recall, you have to write down that one as a review, right? I can easily give you a review, a printed review, doesn't matter, but it doesn't work for you. What you have to do is you have to write down a review by yourself. ඔයා තනියෙන් review එකක් ලියන්න පුරුදු වෙන්න. question එකක් අරගෙන ඒකේ මොනවාද මම කරලා තියෙන අඩුපාඩු. මම මොනවාද ඒකෙන් ඉගෙන ගත්තේ, right? So you have to take the responsibility to not to do the mistake again. ඒ වැරද්ද ආයෙ කරන්න බෑ. So likewise, we are writing reviews, theories, what you have to learn from that question, right? I'm only discussing some questions. I'm going to recall all the theories. You can note down everything that I'm going to write down. So you can include your things into that review book, right? So I can't see your review book because now for the physical students, I can see their physical review book. I told them every day when they come to the class, they have to bring the review book, and I'm going to check that. But for the online students also, you can send me some photographs that you wrote, everything under that day. So I can check that one, right? So writing review is very, very important. This is kind of a evaluation, self-evaluation. ඔයාවම මොකද කරන්නේ? self-evaluation එකක් කරගන්න. හරි? ඔයාවම estimate කරගන්නවා ඔයා මොනවද කරලා තියෙන්නේ කියලා. So review is so important. Remember that one. Why this paper class is so important, right? Why paper class is so important? Before 2023, 2022, 2021, actually no one started the paper class as soon as like this. ඒ කියන්නේ 26 batch එකට 25 batch එකට 24 batch එකට සාමාන්‍ය ගොඩක් ගුරුවරු paper class එක දැන් වේලාසනේ පටන් ගන්න තියෙනවා. දැන් කලින් වගේ නෙමෙයි. The reason, students, to practice you for the papers. The A-level examination එකේ pattern එක තාම හරියට click වුනේ නැත්තම්. හරි? ඒ pattern එක හරියට click කරගන්න. term test වල ලකුණු ගන්න. So ඒකට මේ paper class එක ගොඩක් වැදගත්. That's why so important. Remember, now competition is very high. Competition එක වැඩි. Competition එක වැඩි වෙන්න වැඩ කරන්න ඕන ප්‍රමාණය වැඩි වෙනවා. Can you understand? When the competition is getting higher, you have to work hard. You have to work a lot. So as teachers, we also have to work with you. That's why we are starting this paper class sooner. Actually, I don't like to start the paper class this much earlier for your batch or for the previous batch. Actually, normally the paper class started 1 year before the examination. That is the trend had when we are doing the A-level classes. When I'm going for the A-level classes, our teachers started paper class before 1 year. ඒ කියන්නේ lesson අපි syllabus එකේ පාඩම් 6ක් 7ක් ඉදිරි වුණාට පස්සේ අපි කරන්නේ. But it's not like that. Now the trend has changed. So we have to go to that trend. What to do? Because the competition is so high. When the competition is getting higher, we have to work hard. So remember, students, that is so important. Paper class එකක් ඔයගලන්ට අනිවාර්යෙන් තියෙන්න ඕනේ මේ වෙනකොට. Remember, not only for the chemistry. Those who are doing biology, for biology now you should start a paper class. Those who are doing physics, definitely you all are doing physics, you have to go for a paper class. Those who are doing combined maths also, you have to go for a good paper class, right? So I'm not telling you to attend for my paper class. If you want, you can attend that one. Doesn't matter. You can get the idea, and if it is worth for you, if it is effective, you can attend, right? Remember, for all 3 subjects, you have to attend for the paper class. For my theory students, I have told you that paper class is compulsory for you. අනිවාර්යෙන් paper class එකට එන්න ඕනේ. ඒ වැඩ ටික පිළිවෙලට වෙන්න. Right? Remember, students, when we consider the priority, හරි? මේ priority එක ගැන කතා කරොත්. Remember, students, now for your batch, right? Also for the 25 batch, 40% priority for the theory, right? And 60% priority is for the paper, right? So if you ask me, sir, what is so important? I would say paper. Doing papers is the most important, right? It doesn't mean that doing theory is not important. You have to learn the theories. When you learn the theory, you can do the papers. But I have given the priority 40% for the theory, 60% for the paper. In the phase number 3, we are giving 100% priority for the papers. That's how this is flowed. Can you understand? So I believe that. And one more thing I want to tell you that I have heard and I have seen that some of the teachers are doing the paper classes unit wise. Remember, students, I'm not going to do like that. It's not my way. I'm giving all the things together up to the theories we have covered in our theory classes. Then unit number 3 වෙනකන් cover කරලා තියෙනවනේ, right? We have done something. Then all the questions are from unit number 1, 2, 3 will be given in this paper book number 1 in other paper books also. Can you understand? That is the way that we are conducting the paper class, not unit wise, right? And you don't have to worry. We are going to discuss all the questions, not partially. හැම question එකම class එක ඇතුලේ කතා කරනවා. So you can discuss everything with me in the paper class. Okay, right. So this is the structure. This is the way that we are going to conduct the papers. Okay, right. Then let's go for the first paper. Students, quickly take out the model paper 1 in the paper book 1. And those who cannot attend for the live sessions, doesn't matter. You can watch the recordings as well. Live එකට එන්න පුළුවන් නම් ගොඩක් හොඳයි. Right. Right. Okay, first of all, raise your hand who got an idea about the paper class. Raise your hand who got the idea about the paper class. Quickly. If you have any doubts, put your doubts in the chat box. If you have any doubts, you can put your doubts in the chat box. Huh? Right. Okay. So how we can have the recordings for the physical classes, students? Elindu, don't worry. I'm going to upload the recording for your group. We have a common group name for the physical batch students. For them, I'm going to upload that recording. Huh? Yeah. Recordings are provided, therefore nothing to worry. So will be the paper class. So will the paper class be done every week? Yes. Every week, Monday, the paper class will be conducted. We are going to meet in the live session, right? In addition to that one, we are going to provide the recordings also, right? Soon after completed the next first paper book, the next paper book also, you will get the through post, okay, for the online students, right? Okay, students, without wasting our time, let's go for the So is there a format you can show if the review book of like past month? So Hazik, I told you that this review book idea actually I first of all executed for your batch. 2025 batch actually I didn't give that one for them. I didn't give the review book. So from the next paper book only, they are also going to write down the reviews, right? So why don't you start that one? So I'm eagerly waiting to see your reviews. Okay. So soon after today's class, so you can write down a review about the questions you learn and send me. Right? So you do, that is your part. Eka mage part එක නෙවෙයි. Review ලියන එක ඔයගලගේ part. ඔයගොල්ලෝ තනියෙන් ඔයගලන්ට හිතන දේ ඔයගොල්ලෝ ඉගෙන ගත්ත theory you can write down. Okay. And one more thing, after the class, please send me a feedback, small feedback, positive or negative, whatever it is about the paper class, the session that we conduct. Okay. So writing reviews are part of you. Okay. That means you have to do that one. Right. So let's go for the model paper 1. Let's go for the MCQ paper. First MCQ. Name of the each scientist and their activity is correctly mentioned in. Students, they have given some activities and the relevant scientist. So we know that actually these scientist names are very important when we come to the first question, right? So let's quickly go for the theories that we learned. Tell me quickly, who are the relevant scientists on these activities or these phrases that they have given, right? Look at this one. The first one is they have given the charge of electron. Next one is radioactivity, neutron, and the quantization of energy, right? We know that, students, we learned under the first unit, the charge of the electron was found by Robert Millikan using the oil drop experiment. So the charge of electron is 1.602 10 to the power minus 19 coulomb, right? So this is actually Robert Millikan. So he's the guy who found the charge of electron using the oil drop experiment. And tell me who invented the radioactivity, right? Who invented the radioactivity? So I told you that is Henry Becquerel. Henry Becquerel. Henry Becquerel is the scientist who invented the radioactivity. You have to remember that. Students, tell me who found the neutron? Who found the neutron? James Chadwick. James Chadwick, right? If you can't remember these names, now you can remember these things, recall your memory. Hey, James Chadwick. And tell me who actually invented the quantization of energy. Students, quantization means actually energy also particulate. Can you remember the concept of photon, right? Energy is containing particles. So that kind of a particle is known as photon. So this quantization of energy was found by whom? Max Planck. Max Planck, right? So in order to honor him only, the Planck's constant, H equals 6.626 10 to the power minus 34 joule second. The Planck's constant is introduced. Right? Then make the review. The mama karna review මෙච්චරයි. The ඔයගලන්ට තව ඕනනම් දාන්න බලන්න. If you want, you can put here oil drop experiment, right? අන්න එහෙමයි review එකක් ලියන්නේ. ඒ කියන්නේ ඒක ඔයාට තේරුණාම ඇති. Right? Oil drop experiment. If you want, you can mention the mass of electron, who found the mass, who found the electron, right? So under the neutron, you can find out you can write down what is the mass of neutron, right? So likewise, you can include many things there. So that is review. You have to write. Make a review. Make explanation, right? So likewise, you have to write down everything. Okay, now tell me what is the answer for question number 1. Question number 1 answer. Second one. Raise your hand who got the correct answer for question number 1. Raise your hand who got the answer for correct question number 1. Right, good. Quickly write down everything. Huh? You have to write down everything in the class. Huh? You have to write down everything in the class. පටපටගල් ලියන්න කැත උනාට කමක් නැහැ හරි. ලස්සන මේ කැත උනාට කමක් නැහැ ලියන්න ටක් ගාලා. Should we write reviews for the questions we got wrong only or all questions? Nama, that's a good question. You have to write down reviews for all the questions. Whether it is correct or wrong, you have to write down for everything. Because marks is not our priority, knowledge. So our marks is important in the term test examinations, in our A-level examination. That is the place where the marks are important. In the paper class, the priority is to gain the knowledge, right? To get the idea of writing papers. That is the important. Okay? Marks check right? You have to tell me your marks. Right? Shall we move to the next one? Write down the reviews in your review book. That's why I send you the review book. Quickly. Done. Let's go for the second question. So the second question is related to the electromagnetic spectrum. So those who got the answer, Put your answers in the chat box. උත්තර දන්න කට්ටිය chat box එකේ දාගෙන යන්න quickly. So electromagnetic spectrum. We have discussed about electromagnetic radiations. Under the electromagnetic radiations, we have discussed about the electromagnetic spectrum. Sorry. In electromagnetic spectrum, tell me students, if I consider the frequency increasing order or energy increasing order, first of all, we have to consider TV and radio waves. Okay. Then we have radar. Then we have microwaves, right? Then we have infrared. What is the next one? Sorry. Then we have visible light. Then we have UV, ultraviolet region. Then we have X-ray. At last, we have gamma rays. So remember, students, this is the frequency and energy increasing order. For this direction, energy and frequency increasing. And tell me, for which direction the wavelength is increasing? To which direction wavelength is increasing? We can tell that wavelength is increasing for the opposite direction. Lambda wavelength is increasing for the opposite direction. Right? Remember, students, visible light. What do you know about the visible light? Visible light region, especially we have to discuss about that one. Rainbow colors. So visible light is the only region that we can observe for our naked eye. Another point. You can include that one to your review. Visible light is the only region that we can observe for our naked eye. So tell me, visible light, what are the 7 colors we have? 1, 2, 3, 4, 5, 6, 7. What are the 7 colors? Red color, orange color, yellow color, green color, blue color, indigo, and violet or purple. Can you understand? So these are the 7 colors, visible light. Students, in your resource book, the visible light region they have given wavelength is 400 to 750 nanometers, right? Nanometers, 400 to 750. That means here we have to put 750 nanometers and here 400 nanometers. So this is the boundary line of the visible light that they have given in your resource book. So sometimes actually they have considered, when you search this one in Google or somewhere, in other books, they have given 390, right? In some books, they are considering this is 760. But according to your resource book, they have given 400 to 750 nanometers. Okay. Right. Now you can go for the answer. Radar and radio waves are not the same. No, we are categorizing radar waves separately. Okay. So we can say that some of the radar waves, we can consider them as radio waves. But there are radar waves apart from the TV and radio waves as well. That's why I put here radar waves. Okay. Actually, the radar waves can be categorized under TV and radio waves as well as microwaves. Both are correct. So that's why I separately mentioned at the middle radar waves. Okay. Right. So tell me, students, what is the answer for this one? Which of the following electromagnetic radiations has the highest wavelength? Infrared, visible, radar, ultraviolet, microwaves. Infrared, where is infrared? Here. Visible light here. Then radar waves here. Ultraviolet rays, frequency is greater. Microwaves here. So they are asking which part has the greatest wavelength? Then the answer should go for the radar waves. Question number 2, answer is third one. Question number 2, answer is third one. Quickly, yeah? Raise your hand who got the correct answer for question number 2. Raise your hand who got the correct answer for question number 2. Very good, very good. So quickly write down. Right, okay. Are we done? Shall we move to the third one? Yeah. If you feel like if you don't have time to write down the review, you can roughly note down some these things in somewhere, and later or soon after the class you can write down the review. Right before the next class, you have 1 week, so therefore nothing to worry. Yeah? Because students, we can't conduct the paper class like theory class. Okay, we can't take much time. Quickly, we have to go for the next question. Right. Right. Now let's go for the third question. The electron configuration of iron in the molecule FeO, ferrous oxide, FeO. Right. Let's see. So this question is related to the electron configuration. So you can revise electron configuration for D block elements. So the compound that they have given is ferrous oxide, FeO. So this is ferrous oxide. Remember students, ferrous oxide is made by Fe2 plus cation and O2 minus anion. So tell me quickly, what is the atomic number for iron? What is the atomic number? Iron well? Without looking at the periodic table or anything, tell me 26. So therefore you can say that electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2. 3d6, 4s2 is the configuration for iron. So remember, in this compound, iron is actually in the +2 oxidation state. That means iron atom has removed 2 electrons. So therefore, students, this is ferrous cation, right? Can you remember? Iron is making 2 cations, right? The first cation is Fe2 plus, and the second one is Fe3 plus. Fe2 plus is known as ferrous, the trivial names, and this is ferric, right? IUPAC name is iron, IRO in iron 2, and this is IRO in iron 3. So these are the IUPAC names, right? Ferrous, ferric are the trivial names. So this is actually ferrous cation. Now after removal of the electrons, 2 electrons, valence shell 2 electrons are removed. Then you can say that Fe2 plus configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. Right? So what they're asking here, we can say that the electron configuration of iron in this Fe2O. What is it? 1s2, 2s2, 2p6, 3s2, 3p6, 3d6 is given in the fifth one. Question number 3, answer is number 5. Right? Question number 3, answer is number 5. So raise your hand who got the answer for question number 3 correctly. Finally, you can get a count. Huh? Finally, you can get a count if you want. Right? I'm not forcing you. But you can check whether for first five MCQs, how much I got. For the first 10 MCQs, how much I got. Now, after this discussion of first 10 MCQs, I'm going to ask you who got 10 out of 10. If you got 10 out of 10, you are very good. You are in a good level. 8 or 9 is also shape, somewhat good. If you got less than 7, now that means you have to work hard, right? You have to revise everything again. Right, students, since we are discussing about iron, so why don't we discuss about the other D block elements configuration? So without going for the complete configuration, at least let's try to revise the theory of the valence shell configuration, right? Let me go one by one. You can write down that one for your review. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So these are the D block elements that we have to discuss. So quickly tell me what are the valence configuration. Let's revise that. We can say that scandium 3D1 4s2. What about titanium? 3D2 4s2. Vanadium 3D3 4s2. Chromium 3D4 4s2. Am I right? Am I right? No. Why? Chromium's configuration should be written as 3D5 4s1. Chromium is special. I put a star mark on chromium. I told you that in 3D series elements, chromium and copper, they are rearranging the electron configurations in order to obtain the greater stability. Therefore, chromium's configuration is special. Highlight it. Then what about manganese? 3D5, 4s2. Iron, just now we discussed 3D6, 4s2. Cobalt, 3D7, 4s2. Nickel, 3D8, 4s2. Copper, 3D9, 4s2. Is that correct? No. It should be rearranged as 3D10, 4s1 in order to obtain the greater stability, right? So copper's configuration is also stable. Then what about zinc? Zinc is 3D10, 4s2. So then where may live? So the way that you written, right? You suddenly wrote everything, but we couldn't get like that. I can't do like that, right? So remember, students, this is actually years of practice. I can say, අවුරුදු ගණන් මේ අපි උගන්නලා ඉගෙනගෙන ඒ practice එකෙන් මේ ලියන්නේ. Can you understand? So therefore you have to practice a lot. Then you have to understand how much you should practice. You have to come to my level. ඔයගොල්ලෝ මගේ level එකට එන්න ඕනේ. මාවත් පහු කරලා යන්න ඕනේ. exam එක වෙලාවෙදී ඔයගොල්ලෝ මාව පහු කරනවා. Right? Just imagine you are taking island rank. That means you have passed me. ඔයගොල්ලෝ ඒ level එකට එන්න ඕනේ. If you want to come to that level, students, you have to work hard. මේවා පට ගාලා ඔලුවට එන්න ඕනේ. මේවා එන්නේ නැත්නම් තමයි ප්‍රශ්න. Can you understand? You can do this one. Remember, you can do this one. But you have to practice a lot. Right? Okay, quickly write down this one. So therefore question number 3, answer is number 5. And if you have any doubts, tell me. Students, and one more thing. Some of the students are asking me that about the reviews. A review means they are not paragraphs, huh? They are not essays. I know that those who are doing biology, actually, they can write the essays well. That is not reviews, huh? A biology. So these are something actually you have to write down on point. Can you understand? So this is my review. Okay. I haven't mentioned anything extra. Can you understand? ඔයගලගේ review එක පොඩක් simple වෙන්න ලියන්න, right? But everything should be included there, every necessary thing. Right? Okay, are we done? Question number 4. Let's move to the question number 4. Question number 4, they have given that select the pair of atoms which forms a bond only by the linear overlapping of two p orbitals. Right. Students, this is a good chance to revise the orbital overlapping sigma bonds and pi bonds. Let me quickly revise that one, the theory that we learned, and let's go for the answer. Right. Yeah. Those who know the answer, put your answers in the chat box. Check whether your answer is correct or wrong. Right. Students, we know that orbital overlapping will lead to make covalent bonds, right? Orbital overlapping. And can you remember, there are two types of orbital overlap. So the first type is actually linear orbital overlapping, right? And the next one is lateral orbital overlapping. What does mean by linear orbital overlapping? Linear orbital overlapping means always the bonding electron pair lie on the internuclear axis. Internuclear axis means the axis where the two nuclei are matching. So this is the area you can see the electrons, right? So can you understand that? Electron pair lie on the internuclear axis. So this is the internuclear axis. So these kind of overlapping is known as linear overlapping. Now let's go for the lateral overlapping. What does it mean by lateral overlapping? Lateral overlapping means you can see that these kind of orbitals, they are not actually the bonding electron pairs. Just imagine that the electrons are located here. This bonding electron pair not lie on the internuclear axis, right? Bonding electron pair doesn't lie on the internuclear axis. Actually, it is away from the internuclear axis. So this is known as lateral overlapping. Linear overlapping means, remember, always bonding electron pair lie on the internuclear axis, and in the lateral overlap, the bonding electron pair a little bit away from the internuclear axis. And from the linear orbital overlapping, I told you that sigma bonds are formed. These are sigma bonds. Remember, students, sigma bonds are very strong, isn't it? What is the reason? Because electrons are surrounded by two positive charges, so therefore that's so strong. And these are what? These are pi bonds. Pi bonds are weak. Can I remember? Pi bonds are weak. Because we know that here we can see that two nuclei meeting each other, they are same charge, they will repel. So therefore the bond is tending to break. Electrons are a little bit away. So therefore we can consider pi bonds are weak. So this is linear orbital overlapping and the lateral orbital overlapping. Remember, students, when you go for the linear orbital overlapping, right? Linear orbital overlapping is possible between S and S, S and P, P and P, right? And we can, since we have discussed about the hybridization, we know that between hybrid orbitals, right? So there are so many possibilities to linearly overlap. S and S orbital can linearly overlap. S and P orbital can linearly overlap. P and P orbital can linearly overlap, right? And hybrid orbitals also can linearly overlap. But remember, lateral overlapping is always taking place, right? Always in between P and P orbital. Remember that one, P and P orbital. Later, we have discussed these things under the theories. Now go for the question, right? So look at that, look at the review. Very simple. I can revise everything I learned. Select the pair of atoms which forms a bond only by the linear overlapping of two p orbitals. Students, when you look at the answers that they have given, can you tell me what are the orbitals involved in the formation of these bonds? Hydrogen, hydrogen. Hydrogen, hydrogen is formed by 1s orbital is linearly overlapping with another 1s orbital in hydrogen atom, right? When you consider the second one, oxygen, oxygen, we know that oxygen, oxygen, there is a pi bond, right? There is a pi bond, sigma bond, both are there. So therefore, the sigma bond is made by how? How it is made? We know that 2p atomic orbital, linearly overlapping. And pi bond is made by 2p atomic orbital, laterally overlapping. So by linearly overlapping 2p atomic orbitals, sigma bond is formed. By laterally overlapping 2p atomic orbitals, a pi bond is made, right? So likewise, when you go for the HCl, how that HCl is made? In HCl, we know that 1s atomic orbital and 3p atomic orbital, 3p, third principal energy level, p sub energy level, orbital is linearly overlapping in order to make this HCl. And the next one is nitrogen, nitrogen. What do you think about nitrogen, nitrogen? Remember, sirs, nitrogen, nitrogen, Lewis structure, there is a triple bond. Again, a bond තුනක් තියෙනවා. So when there are multiple bonds, we know that one is sigma and the other two bonds are pi bonds. So here we can say that anyway, whether it is sigma or pi, we can say that 2p atomic orbitals are overlap in order to make these bonds. They're asking number 5, chlorine, chlorine. We can say that chlorine, chlorine is made by there is only a sigma bond, 3p atomic orbital, 3p atomic. The question is, select the pair of atoms which forms a bond only by the linear overlapping of 2p atomic orbitals. We can reject hydrogen, hydrogen, we can reject HCl. So that means we have 3 options: chlorine, chlorine, oxygen, oxygen, nitrogen, nitrogen. All of them have used their p orbitals to make the bond state. But remember, students, in the question they have given only by linear overlapping. We know that oxygen and nitrogen, they are containing multiple bonds. In order to make the multiple bonds, pi bonds are there. Pi bonds are made by the lateral overlap. Rejected. Oxygen, oxygen, nitrogen rejected. Only the answer that we can take is chlorine, chlorine. Because chlorine, chlorine bond, that's a single bond. The single bond is made by linear overlapping between 3p atomic orbital and another 3p atomic orbital. So therefore, question number 4, answer should be what? Number 5. Question number 4, answer should be number 5. Quickly raise your hand who got the correct answer for this question number 4. Raise your hand who got the answer for question number 4. Okay, very good. So there are many. Okay. Keep it up. Remember, students, you have to set small targets. Can you understand? In life also, you can apply that one. You can't achieve big targets at once. Can you understand? First of all, you have to go for small targets. Now, in this paper book, first of all, you can try how I can get correctly the first 10 questions all the time, right? Remember, students, actually these tricks are followed by students, many students, right? They are telling that they can do the first 10 questions within first 10 minutes in the level examination without making any mistake. That much they are confident. So how that confidence made? That confidence is came by doing papers, doing questions, right? That is the first target, right? So now in the first day of the paper class, I'm setting you a first target. Try to get the 10 out of 10 for the first 10 MCQs. Right? ඊළඟ දවසේ ඉඳලා 15, 20, 25. Right? After that, we are going to discuss essay questions. Essay question එකේ අමාරුයි ලකුණු ගන්න, right? It's very difficult to take marks in essays. You understand? So let's see. Step by step, you have to go forward. Quickly complete this up. Remember, students, getting A for chemistry or any other subject is not a, it's not a 1 day or 1 week process. Actually, it's a long time process. Again, අවුරුදු ගානක මහන්සිය ප්‍රතිඵලයක් තමයි ඒ කියලා කියන්නේ. You understand? ඒකක් ගන්නවා කියන්නේ lazy නෑ. It's not easy. You have to work hard, right? It's a long time process. Have you heard a quote like that? This success is not a but destination, it's a journey. And ඔයා යන ගමන තමයි success කියලා කියන්නේ. So here also, how you are going to spend your this 1 year 2025 will affect to 2026, right? They are dependable. Huh? Shall we go to the question number 5 quickly? Okay, right. Students, let's go for the question number 5. Question number 5, I think they have given from the oxidation, right? I think it's very easy, right? So this reaction is very famous. We are learning this reaction in organic chemistry. Plus, remember this molecule is an alkene, right? Double bond is there. This is known as propene. So for propene, we are adding hydrogen. They have given that hydrogen molecule is added. So what will happen is hydrogen is breaking and this double bond is breaking. So one hydrogen is going here and the other one is going towards this carbon and making alkane, CH3, CH2, CH3, this kind of a, right? So for our convenience, let me spread the bonds. Then we can easily count the oxidation numbers, right? Right. Look at the statements they have given: capital A, capital B, capital C. The hybridization of carbon A. Carbon A means this one. This is carbon A, carbon simple A, and this is carbon simple B. The hybridization of carbon simple A changes from sp2 to sp3, right? Students, hybridization theory, how you can determine the hybridization? In order to determine the hybridization, you have to count the VSEPR electron pairs. If not, we can say that non-pi bonding electron pairs, right? Non-pi bonding electron pairs. So, and here we can say that this is the hybridization. If you count the, so non-pi bonding electron pairs means, remember that sigma plus lone pairs, right? Another name that we can use is VSEPR electron pairs, VSEPR pairs, right? If non-pi bonding electron pairs are 2, we can say that hybridization is sp. If it is 3, we can say that sp2. If it is 4, we can say sp3, right? If it is 5, sp3d. D orbitals are also involved in the hybridization. We discuss about these things in theories, huh? sp3d2, right? Now you can decide what is the hybridization of the carbon atom. So this is the first carbon atom. Then you can see that this is sp2, 1, 2, 3. There are three VSEPR pairs, therefore hybridization is sp2. What about the second B carbon atom? So that is also sp2, sp2. So when you go for the molecule that we obtain from the reaction, after the reaction, so this carbon is actually surrounded by 4 VSEPR pairs. If it is 4 VSEPR pairs, we can say that hybridization is sp3. And here also 4 VSEPR pairs, hybridization is sp3. So sp2 hybridized carbon atoms are completely changing into sp3 hybridization by the reaction with hydrogen. Can you understand? Right. Now, you can see that the capital A statement that they have given is perfectly all right. That's correct. Let's go for capital B state. Capital B statement says that the oxidation number of carbon A changes from -2 to -3. Right, students, we know that in order to take the oxidation state using bonds, now we have drawn the structures. No, these are not the perfect Lewis structures because in here actually I haven't spread the bonds, but this notation you have to remember. In organic chemistry, we are learning these kind of notations without writing, without spreading these carbon hydrogen bonds. Directly we can write down CH3. Okay, in organic chemistry you will learn these things. Okay? So students, we know that in order to find out the oxidation number using the bonding method, we have to find out the electronegativity difference. Tell me students, according to the Pauling scale, carbon, hydrogen, who is the most electronegative? Carbon or hydrogen? If someone can tell the oxidation number values, that will be very nice. Anyone? Can anyone try what is the, sorry, electronegativity value of carbon and hydrogen? Electronegativity values of carbon and hydrogen. Can anyone remember? What is the electronegativity of carbon? Yes, Sukulma, correct. Carbon is correct. Very good. What about hydrogen? Hydrogen is, yes, correct. 2.1. Yes, yes. Friends, tell me, there is another element that we have 2.1 electronegative value similar to hydrogen. Who is it? Phosphorus. Very good. So therefore, we can say that carbon is 2.5, hydrogen is 2.1. So therefore, we can assign +1 for hydrogen, -1 for carbon, +1 for hydrogen, -1 for carbon. And we know that students, between these two carbon atoms, there is no electronegative difference. Directly, you can take that oxidation number for this carbon atom is -2. Right? So that -2 is changing into what? May? Here also we can see that carbon is surrounded by 4 Weber pairs, +1, -1, +1, -1, +1, -1. Carbon, carbon, there is no difference. Oxidation state of carbon is -3. So students, you can see that carbon's oxidation number has been changed from -2 to -3 in this reaction. -2 to -3 in this reaction. Can you understand? So therefore, the statement that they have given, simple B statement, is also perfectly all right. C, the oxidation number of carbon B, this one, changes from -2 to +3. Actually, when you look at the second carbon atom they have given, students, you know that this carbon is connected to a carbon atom through a double bond. Therefore, no difference. Electronegative difference is 0. And here also carbon is there. No difference. So only carbon hydrogen bond is there, +1, -1. Oxidation state of this carbon atom is -1. Oxidation state of this carbon atom is -1. Now go for that carbon atom in the next molecule. Here you can see that carbon is surrounded by 2 carbons and 2 hydrogen, +1, -1, +1, -1. Here carbon's oxidation number is -2. So in the second carbon atom, B carbon atom, oxidation number is changing from -1 to -2. So therefore, capital C statement they have given is wrong. We can't accept it. Capital A, capital B, only. Question number 5, answer is first one. Question number 5, answer is first. So this is actually now look at this one. In this question, how many theories we learn? The May question just imagine how many theories we learn. For an example, you learn about the oxidation now. You learn about the electronegativity. You learn about the hybridization. And you know how to count the Weber pairs, right? And I told you that this is application of a organic chemistry. So likewise, in a question, we can learn many things. That is the advantage of doing questions. Right? Raise your hand who got the correct answers for first 5 questions correctly. Pahim pahama hari. Raise your hand. Those who got the answers 5 out of 5. First 5 answers correctly. Okay, good. Right. Good, no? Very good. So others, don't worry. This is just the beginning. Little by little, you can increase your marks. Huh? Right, okay. Are we done? Quickly write out these things. If you have any doubts, put your doubts in the chat box, students. Elidu, sir, can you tell the group and period in which all the physical state of atoms are existing? Group and the period. I always get confused in those numbers. So remember, Helindu, the only group that exists all three states of matter. What is it? Group number 17, right? Fluorine, chlorine, bromine, iodine, acetylene. Right? Fluorine, chlorine, we know that they are gases. Bromine is a liquid. And then what is iodine and acetylene? They are solids. And the period wise, when we consider bromine and mercury is there. So they are actually in the group number 4 and 6. Period number 4 and 6. So therefore, the all three states of matter can be seen in group number 17 and period numbers 4 and 6. Are we done with this? අපි යන්න ඊළඟට ටක් ගාලා ලියන්න ඕන හරි. Right, okay. Are we done? Shall we move to the next question? Question number 6. Question number 6. Select the element shows the positive electron gain energy. Students, remember positive electron gain energy. Electron gain energy. What does mean by electron gain energy? That means the energy related to gaining electrons. Delta E, Eg, electron gain energy. Remember, you have to remember few important things under the electron gain energy. So electron gain energy means we can consider that gaseous state atom, 1 mole of gaseous state atom is taking 1 mole of electrons in order to form gaseous state, monovalent, anion 1 mole at the standard condition. So this is known as electron gain energy, delta E Eg1. So remember students, most of the electron gain energy values are negative, right? Most of the values are negative, right? But there are few elements that you have to remember. They have positive electron gain energies, right? So what does mean by these positive values and negative values? What does mean by this positive sign and the negative sign? Now, for an example, the most highest the electron gain energy value belongs to chlorine. In your resource book, they have given chlorine's electron gain energy. This is Cl minus. This is delta E Eg. This is equal to 349 kilojoules per mole. So this is the electron gain energy value that they have given in your resource book. And remember, students, this is the greatest value of 349. Remember, this negative sign is representing that energy releases. Can you understand? Energy releases. We are going to learn this one in enthalpy also, unit number 5. Energy releasing means it's exothermic. It's exothermic, right? Write down these things. If it is a positive value, we can say that the energy is absorbing, right? Energy absorbs. Energy releases when it is negative. Energy absorbed when it is positive. This is known as endothermic. Endothermic, exothermic and endothermic. You have learned this one in your O-level time also, right? So energy releases means it is very stable. Energy absorbing means in order to gain an electron, we have to give energy, right? That's why it is positive, somewhat unstable. That means we have to do a work. So there are 3 elements that we have to remember. Those are having positive electron gain energies. Who are they? You have to remember beryllium, nitrogen, magnesium. They are having positive electron gain energy values. Delta E, Eg is always positive for them, greater than 0. Positive values. Okay? Positive values. Right? So remember, as a summary, you can understand that electron gain energy means gaining electron. Most of the values are negative. Negative means in the sense we can tell that they are releasing energy, exothermic. And positive means they are absorbing energy, unstable, endothermic. Remember, students, the highest value, the greatest value belongs to chlorine, 349. The negative sign is representing that it is releasing energy, right? And one more thing, in your resource book, actually, they have given for nitrogen and beryllium also. So therefore, let me write down electron gain energy for beryllium. Beryllium gas gaining electron to produce beryllium minus gas. This is a positive value, delta EEG. The value that they have given is for beryllium 231 kilojoules per mole. Students, better you remember these things since they have given in the resource book. Nitrogen gas producing N minus gas by gaining electron gain energy value is 134 kilojoules per mole. These are the values that they have given in your resource book. Magnesium value is not given in the resource book. So therefore, I don't want to discuss that one. Okay, right. So this is the summary that you have to take under the electron gain energy, right? And the next thing, another point is there, always second electron gain energy is a positive value. Always second electron gain energy is a positive value. Why? Because students, if someone is negatively charged, we are trying to give an electron. If someone is negatively charged, we are trying to give an electron. So then what will happen? The electrons are negative, negative repulsions will take place. The repulsion will create there. So because of that repulsion, they have to do a work. In order to gain an electron, they have to do a work. Then energy absorbed endothermic. So remember that point, right? Take the red color pen and write down. Second electron gain energy for any element is a positive value. Second electron gain energy for an element is positive value. Right? Write down that one in your review. Second electron gain energy for any element is a positive value. Right? Okay, now tell me, select the elements show positive electron gain energy. Chlorine, sodium, nitrogen, fluorine, aluminium. What is the answer? Question number 6, answer is third one. Raise your hand who got the answer for correct answer for question number 6. Right, okay, very good. Can you explain again why it becomes positive second electron gain energy, Asma? Yes, Asma. Now just imagine this X minus. Second electron gain energy means for this X minus, you are trying to give an electron, right? Now look at this one, X minus is an anion. Anion means we can say that we have an extra electron negatively charged. Someone is negatively charged and you are trying to give an electron for that negatively charged species. Will it accept? Will it accept? It can't accept. Why? It is already negatively charged. It has an extra electron. If it is containing extra electron, in order to give the second electron, what will happen? That will be a positive one. So then some of the anions are producing S2 minus, N3 minus kind of charges are there. More than one negative charge is there. Yeah. The reason why they are gaining 2 electrons, 3 electrons, the reason is in order to obtain the greater stability. Now, for an example, sodium-like element, why it should take electrons? Right? No point, right? If you are trying to give electron by forcefully, definitely we have to do work. So that's what I'm talking here. Electron gain energy means giving electrons by forcefully, right? Then it is a positive value. Question number 6 is done. Right. Electron affinity. What is electron affinity? Electron gain energy. We can tell that electron affinity is equal to negative of the electron gain energy. Negative of the electron gain energy, which means we can consider that chlorine's electron gain energy is negative value minus 349 kilojoules per mole. Then what is the electron affinity of chlorine? Electron affinity of chlorine is plus 349 kilojoules per mole, right? Remember, electron affinity means completely opposite of the electron gain energy. Completely opposite of the electron gain energy. Right? Write down that one also in your review. Better you remember these values. Huh? Shall we move to the next question? Question number 7. Are we done with this? Yeah. Question number 7. Question number 7 is related to the periodic table. Question number 7 is related to the periodic table. Let's see. So they have given which is not true, right? And one more thing, remember, when you are doing questions in the chemistry paper MCQs, they have given not true. Okay, if not, they are giving true statement. So they have given incorrect statement, right? They have given correct statement. Right? So you have to be careful with these terms. Huh? Read the question well, right? Sometimes in the question they're asking not true statements, but you are giving the answer for the true statements. In the question they're asking incorrect statements, but you are giving answer for the correct statements, right? So watch carefully, read the question 2-3 times. That's better. Question number 7, which is not true regarding the modern periodic table? Majority of the elements present in the periodic table are metals. Students, what we learn under the periodic table? Let me take a quick revise of this one. We know that periodic table, 80% are metals, right? As a fraction, we can say that 4/5, right? Then we know that in the periodic table, we have metals, non-metals, metalloids. Then tell me, we have amphoteric elements in the periodic table. Who are the amphoteric elements? Quickly. There are 5 amphoteric elements. Who are they? Amphoteric means we know that the elements which can react with both acids and bases, right? Starting from beryllium, aluminium, tin, lead, zinc. These kind of elements are there. And remember, periodic table is based on atomic number, and then electron configuration. Atomic number and the electron configuration. Okay. And this point actually should be mentioned in as the first point. Who developed the modern periodic table? Dmitry Mendeleev. Mendeleev. Okay. Then what else we learn? So how many groups are there in the periodic table? How many groups are there in the periodic table? Quickly tell me. How many groups? How many periods in the periodic table? Yeah. Correct. Anuha's correct. What about the others? How many periods are there? Okay, groups are correct. Correct. Okay. Akma correct. Yes. So I believe that you all can remember these things, huh? Remember, students, there are 18 groups and 7 periods in the periodic table. So likewise, we can take a summary about the periodic table. We have already discussed about these things in theories. So let's go for the question. Majority of the elements present in the periodic table are metals. Is that correct? Yes. First statement is correct. Among the elements of the P block, there exist the elements belong to 3 states of solid, liquid, and gas. Among the elements of the P block, there exist elements belong to 3 states: solid, liquid, and gas. Is that correct? What do you think? In the P block, can we see all 3 states of matter: solid, gas, liquid? Yes. So I told you that, remember, when we consider the group number 17, what are the group number 17 elements? Group number 17 elements are halogen elements. So these halogen elements are fluorine, bromine, iodine, and astatine. So remember, fluorine and chlorine. They are gases. Bromine is a liquid. Okay? And iodine, astatine, they are solids. So therefore, you can see that in group number 17, all 3 states of matter. Group number 17 belongs to P block of the periodic table. Therefore, that statement is correct. The modern periodic table is prepared based on the atomic number. Yes, correct. Ne? I told you that based on atomic number as well as configuration. So since they have given based on atomic number, correct. Yeah, nothing wrong with that statement. Number 4, nuclei of all elements of the periodic table have protons and neutrons. Students, why? Yeah, this statement is wrong, right? This is the not true statement. Why this is not correct? All the elements are having protons and neutrons, right? Hydrogen, can you remember in the first unit I discussed about hydrogen? Hydrogen is the only element which is not containing neutron, at least one neutron, right? hydrogen element is made by hydrogen 1 1. This is made by 1 electron and 1 proton, right? So that's why we consider hydrogen is the lightest element in the periodic table. Can you understand? So therefore, 1 electron, 1 proton, there is only one element in the periodic table which doesn't contain at least one neutron, 0 neutron, that is hydrogen. So the statement that they have given is wrong. So question number 7 answer is 4. But let's go for the last statement also. Within first 6 periods of the periodic table, there are 11 elements which exist in gases at the room temperature. Students, we discussed this one. We completely discussed this one. I told you that there are 11 gases in the periodic table. Can you name them? What are the 11 gases? Recall that one quickly. What are the 11 gases in the periodic table? Gases, gaseous state elements. Let's start from the period number 1. We have hydrogen, then we have helium. Then go for the period number 2. In the period number 2, we can start from nitrogen, oxygen, fluorine, neon. Then go for the period number 3. At there we can see we can take chlorine and argon. Okay? And then who else? When you go for the next period, we can see that krypton, xenon, radon. Right? When you go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, there are 11 gases in the periodic table. Right? We know that helium, neon, argon, krypton, xenon, radon, they are known as noble gases. Group number 18. Ne? So therefore, the number 5 statement is correct. Ne? So question number 7 asks is number 4. Raise your hand who got the correct answer for this one. That is completely theory. Students, you should be able to get the answer for that. Right, okay, good, very good. There are many. Right, you can understand now just by doing one question how many theories, how many things we can recall. Right, try to understand doing papers, try to understand the advantage of writing review for these questions. Lassana review එක clear. Write down a beautiful and effective review in your review book. වැඩ කරන්න හරි. For the English medium students, actually remember there are no such good paper classes, online paper classes, where I believe that there are only few. So therefore, I believe that I'm conducting for the online very well. With the 25 batch, I conducted that one for 1 year and we are still doing well. So I hope to do that one. I hope to continue that one with you. I'm trying to do that one with you perfectly, okay? Quickly get the summary. Question number 8. Shall we move to question number 8? Yes. So what is the physical state of OG organism? Yes, that is solid. No? It is radioactive. It is radioactive. Normally we tell that the physical states are solid, liquid and gases. These are the 3 physical states that we have to discuss. But actually More than that, we can consider aqueous is also some kind of a physical state, aqueous. And those who are those who are doing biology, I think there is another physical state that is not exactly physical state, a plasma state. I have heard of something like that, but mainly we have solid, gases, and liquid. Okay. In the periodic table, we categorize all the elements as solid, gases, and liquids. Right? Students, now let's go for the question number 8. Question number 8, they have given. Are we done with this one? Shall we move to the question number 8? Yeah. The number of resonance structures can be drawn for the bicarbonate is, right? Students, resonance structures. What does mean by resonance structures? Resonance structures means ability to draw. Resonance means ability to draw more than one Lewis structure for a molecule. More than one Lewis structure for a molecule. Right? So, bicarbonate, it's CO3 minus. How many Lewis structures we can draw for bicarbonate? Now look at this. So, bicarbonate, carbon is the central atom and it is surrounded by in this way. I'm drawing that one with the correct shape. In this way, right? And here we have another structure. So what you have to do is you have to shift the double bond everywhere. When you are drawing the resonance structures, what we have to do, you have to shift the double bonds and triple bonds everywhere possible by keeping the total number of bonds constant. And then we can see here. Right? And we can draw another structure. Put a double bond here. Here oxygen is negatively charged. Negatively charged. And here oxygen is positively charged. Right? Okay, students, you know that when we are drawing resonance structures, remember you have to put this double head arrow. This double head arrow is very, very important, okay? So in order to denote the resonance structures, this is the symbol we are using, double head arrow from both sides. So these are the resonance structures that we can draw for bicarbonate, HCO3 minus, right? Can you understand? So if I ask you, now this is additional thing, but I'm asking you, which structures are stable? Number 1, number 2, number 3. If I consider these 3 structures, which one are stable and which one are unstable? Right? Can you say that one? So remember, number 1 and number 2, both are stable compared to the third one. Number 1, number 2, both are stable, but number 2, number 3 is unstable. Unstable. Right? So first one and second one both are unstable because of what? Less charge separation. Right? Less charge separation. Can you remember when we are comparing the stability? I told you there are few things to consider, right? Charge separation. If there is a less charge separation, we can say that that element is, that atom is what? Stable. That structure is stable. And we can consider if the most electronegative atom has the negative sign, we can say that that is stable, right? If adjacent atoms are having positive charges, we can say that that is stable. So therefore, when you compare these three, we can say that less charge separation. And the next thing is oxygen has a negative charge because oxygen is the most electronegative atom in this structure. Negative charge, right? So the same two reason can be written here as well. I'm not going to repeat it. You just write down that one. What are the reasons for the instability compared to the first two structures? Here you can see that two charges are there, three charges are there, minus, minus, plus. So therefore here we have a greater charge separation, right? Since there is a greater charge separation, we can say that is unstable, right? Greater charge separation. And another reason we can say that oxygen may, the most negative electronegative oxygen atom has a positive sign. The most electronegative, the most electronegative oxygen, oxygen has a positive sign. So that is actually reason for instability. Can you understand? Right? So likewise, we can give the reason for the stability or instability like this. Right? Normally, these kind of questions are given in the structured essay paper. In the first structured essay question, students, they are giving the first question is actually they are giving the skeleton, and you ask to draw the most acceptable structure. Then they are asking the resonance structures. Sometimes they are asking to compare the stability of these structures. Then they are asking what are the bonds in between atoms. Then they are asking what are the orbitals involved in these bonds, formation of the bonds. So likewise, they are asking few question patterns are there. So let's go for the essay paper, then you will understand. Right. So we can draw one, two, three resonance structures. Question number 8, answer is 2. Do we have more than these? Do we can we draw more than these 3 structures? So what about if I put the double bond between oxygen and hydrogen? That's wrong. You are killing chemistry on the spot. We can't do that one. Why? Can hydrogen make double bonds? Hydrogen has only 1 electron. It can keep only 2 electrons in the valence energy level. So therefore, hydrogen is not making double bonds. So therefore, there is no possibility to shift the double bond between oxygen and hydrogen. Only 3 positions. Therefore, 3 resonance structures. Question number 8. Answer is second one. Raise your hand who got the correct answer for question number 8. Good, very good. Yes. Yeah, good, very good. Right, okay. Shall we move to question number 9 and 10? Students, in question number 10, there is a small correction. Question number 10, third answer should be 3 into 10 to the power minus 19. Question number 10, third answer should be 3 into 10 to the power minus 19. Correct that one. Right, are we done? Shall we move to the next one? Number 9 and number 10. Right. Question number 9. Students, question number 9 is related to a calculation. Can you remember? Energy equation. So they have given, considering the following informations, answer the question number 9 and 10. A radiation having a frequency of 656 nanometers causes to form the first line of Balmer series of the atomic spectrum of hydrogen. So Planck's constant and the velocity of light is given. Select the suitable energy levels for the hydrogen atom to occur the relevant electron transition to form the above mentioned line. Students, they have talked about the Balmer series, right? So this is a good chance to revise the hydrogen emission spectrum. Can you remember? The most important theory part that we learn under the number 1, hydrogen emission spectrum. So in the hydrogen emission spectrum, we know that students, when the electrons are moving from one energy level to another, several series are obtained, right? Several series are obtained. 1, 2, 3, 4, 5, and 6. I think this is enough, right? N equal 1, n equal 2, n equal 3, n equal 4, n equal 5, n equal 6, right? So write with me, draw these things with me, okay? Don't stay without writing this one. So I know this one, therefore no need to write down. No, don't think like that. Be humble. නිහතමානී වෙලා මේවා ආයයි කරන්න, හරි? So this is the first electron transition, n equals 6 to 1. Then this is 5 to 1. Then we have 4 to 1. Let's take that one a little bit closer to this. Right, okay. So what is this series? All the electron transitions which are falling to the first principal energy level is known as what? Lyman series. Students, tell me, Lyman series lie on the which region of the electromagnetic spectrum? Quickly tell me, which region of the electromagnetic spectrum? Ultraviolet region. Ultraviolet region. Ultraviolet. Now let's go for the next one. So the next electron series that we can observe is Balmer series. And we have discussed that 4 lines, the very first 4 lines of the Balmer series can be seen from our naked eye. Only 4 lines, right? All the electron transitions falling to the second principal energy level is known as Balmer series, right? Balmer series belong to, we cannot tell that exactly visible light region. We tell partly visible region, okay? Partly visible light, partly visible light. Remember, so the first line that we observed, n equal 3 to 2, is known as H alpha. This is H beta, H gamma, and H delta, right? What is the color of H alpha? Red color. Okay. Then what about H beta? That is green color. What about this one? Blue color, and this is violet color. So this is the only line series that we can see for our naked eye, right? Because of these 4 colors, red, green, blue, violet, we can see them. So after violet color, the visible light region is over, right? Then the next electron transitions, that means n equals 7 to 2, 8 to 2, they belongs to which region? Ultraviolet. That's why they have given partly visible light region. I have discussed this part in the theories also. Right, now let's go for the partition. Partition means all the electron transitions which are possible for the third principal energy level. Then we have bracket, fund, either Humphrey. Likewise, they have so many series that we can know. So mainly we are discussing about Lyman Balmer Paschen. Paschen belongs to which region? IR. Bracket and fund, they also belong to IR region. So students, they have discussed about the in this question, they have discussed about the line which is obtained in the Balmer series, right? Balmer series means the electron transitions which are falling to the second principal energy, right? Now you can choose the answer. But one more thing, can you tell me, students, for which direction energy should increase? Energy and the frequency should increase for which direction? Right to left or left to right? Energy should increase for which direction? Left to right or right to left? In this hydrogen emission spectrum? Definitely, yes. We have to tell that energy and frequency both increase for the left to right, and the lambda wavelength decreases for that direction. Okay, right? So the answers that they have given, n equal 3 to n equal 2. Is this correct? Yes. This is a line obtained from the Balmer series. The first line, yes, this is the answer. 2 to 3 is not correct, so we don't have to look at the other answers. You can just get the answer. N equal 3 to n equal 2 is the first line we can obtain in the Balmer series. So question number 9, answer is number 1. Question number 9, answer is number 1. Students, this is related to the hydrogen emission spectrum, right? Hydrogen emission spectrum theory. Raise your hand who got the answer for the question number 9 correctly. Right, very good. There are some students. Okay, very good. No? So quickly draw the emission spectrum. Right, okay. Are we done? Right. Now let's go for the question number 10. Question number 10 is actually the calculation. So can you remember the energy equation? Using the energy equation, we can do the calculation. Go for the answers. Quickly go for the answers. Right. Now, question number 10, they're asking the energy of a photon of the above radiation with that wavelength. So the wavelength of this radiation they have given 656 nanometers. So students, we know that according to the theory that we learn, energy is directly proportional to the frequency, energy of a photon. Then this, in order to remove this proportionality symbol, we derive an equation E equal h nu, right? So E means actually energy of a photon, right? Revise the theory quickly. Energy of a photon. What does mean by H? H means Planck's constant, right? H means Planck's constant. What is the Planck's constant value? Planck's constant value is 6.626 10 to the power minus 34 joule seconds. So mu means frequency. Mu is frequency. Then we have C equal nu lambda. So C means velocity of light. Velocity of light, that is 3 into 10 to the power 8 meters per second. And nu is the frequency again. And lambda is the wavelength. Okay. So then we can combine these two equations, number 1 and number 2. By combining these two equations from number 1 and number 2, E equal h nu. So here nu equals C over lambda. You can substitute that one, hc over lambda. Then we are obtaining an equation like E equal hc over lambda. So E means energy of a photon, right? Remember, students, sometimes in questions they're asking what is the energy of a photon mole. Then you have to multiply this one by Avogadro number, hc over lambda multiplied by L. That means E mole. We can tell that E mole, energy of a photon mole, right? So this is energy of a photon mole. Energy of a photon mole is equal to hc capital L over lambda, right? L means Avogadro number. Avogadro number is equal to 6.022 10 to the power 23 per mole, right? Everything we discuss under the theories, right? Shall we go for the calculation then? Energy of a photon of the above radiation with that wavelength, right? Okay. Now look at this one. So we can easily use here equal hc over lambda equation, right? Equal hc over lambda. Planck's constant 6.626 10 to the power minus 34 joule seconds. And velocity of light 3 into 10 to the power 8 meters per second. Divided by lambda. What is the lambda value? 6.56 10 to the power minus 7 meters. What do you say? Is that correct? Students, we know that lambda 656 nano. Nano means what? Nano means 10 to the power minus 9 meters. You can shift the decimal point 2 times backward. Then 6.56, then you can reduce the power by 2 minus 7. That's why I put here 6.56. In theories, I discussed 10 questions as example questions in the class. Can you remember? So we discussed these kind of questions, right? Then we can say that this is 6.56 to the minus 7. Right. Students, are we going to use logarithms to do this calculation? What do you say? Are we going to use logarithms to do this calculation? No, never. So why you told that to use the logarithms correctly? In the essay paper, in order to get the accurate answer, you have to do that part. Students, look at the 5 answers they have given. Podda papers karandi kapati wenna one, right? You have to be a little bit cunning when you're doing the papers. Right? So remember, look at the answers they have given. Everything is 3 into 10 to the power something. 3 into 10 to the power something. First one is 10 to the power minus 30. 10 to the power minus 13. Third one, I told you to correct that 1 to the power minus 90. 10 to the power minus 28. 10 to the power minus 12. So likewise, they have given 10 to the power values. Okay? 10 to the power values. Then students, try to understand here. We don't have to simplify this 6.626 divided by 6.56 multiplied by 3. We don't have to go for the correct answer, accurate answer, right? What we have to do is, already they have given in all 5 answers, answer is 3 into something. Already we can see 3 in the answer. That means they have assumed that when you divide this one by this, answer is number 1. Yes, actually the answer is 1.0, something like that only will come. So therefore, nothing to worry about this one. You can cancel off these two. According to the answers they have given, now, mathematically it's wrong, right? What I have done is wrong. But remember, here not the maths, it's not the issue here. We have to go for the answer, right? Our concern is about chemistry. So therefore, in order to go for the answer, we can cancel off them because all the answers are containing then equal 3. Look at the units. Meters cancel off, second per second cancel off. Then we can see that 10 to the power minus 34. Here we can see that 10 to the power minus 7. So therefore 10 to the power minus 7 will go for the numerator as plus 7. Then plus 8 plus 7 plus 15. 10 to the power 15. So what is the unit? Joules. And then equal 3 into 10 to the power minus 35, 15. What is the answer? Minus 35 plus 15. What is the answer? Answer is 19. Minus 19 joules. In order to convert this one into kilojoules, they are asking the answer in kilojoules. What we have to do? In order to convert this one into kilojoules, what we have to do? Joules into kilojoules. What we are doing? We are dividing that one by 1000, right? Dividing that one by 1000 means dividing by 10 to the power 3. Dividing by 10 to the power 3 means you are multiplying that one by 10 to the power 3. Minus 19, 10 to the power 3. So therefore 3 into 10 to the power minus 22 kilojoules. Kilojoules is the answer. Energy of a photon can be obtained 3 into 10 to the power minus 22. Yes. So will the paper book be sent to our doorstep, or do we need to get the printout ourselves? I think you are not my theory students. For my theory students, physical and online, both theory students, I gave the paper. I send their paper book to their home through post. That means you will get the tutorial to your doorstep. Those who are for those who are coming for my theory class. Now I know that in today's session, there are some students, actually those who are not coming to my theory class. So soon after the today's class, you can do the reservation. You have to contact our class coordinator. She will send you a message in the group. And after that, I can send you a tutorial. Okay. So that process will be deal with our coordinators. Okay. So don't worry about that one. After the class, she will send you a message. Right. Okay. Then what about this question calculation? Right. So what is the answer? 10 to the power minus 30 minus 13 minus 19 minus 28 minus 12. So no answer, right? They haven't given any answer. Then what we have to do? If you have any answer, remember, sometimes you also have to face this kind of a situation in the examination. Actually, this is actually typing error. Okay, that minus 12 should be minus 22. But anyhow, remember students, in examinations, when you analyze the past papers, you will see that for some questions they have given all. Have you seen that one? The reason is they have done something. That means they have done a mistake. If not, the question is wrong. Theory part is wrong. No any answers for that question. In that case, you will be given all. That means it's kind of a free answer, free mark. So for this question also, answer is 3 into 10 to the power minus 22. But since no answer there, all. That means you will get free mark. According to this question, what to do? We have to put 4. But anyway, tell me, raise your hand who got the answer exactly as 3 into 10 to the power minus 22. Raise your hand who got the answer as 3 into 10 to the power minus 2. That's what I want to know. Right, very good. Yes, there are many. Nice. Okay, good, huh? Very good. Okay, now just now we completed the 10th question while discussing all the theories. Huh? So today is the first day. That's why I'm discussing this much of theories. Little by little, I'm reducing. The theory discussion I'm going to reduce, but don't worry. I know what is the rhythm and everything. I know what to do. So since it's the first day, I'm discussing everything perfectly as much as I can, right? So therefore, from the next day and next day onwards, now you have experiences, right? By the time you will get the experiences, you will be able to write down everything by yourself. Okay. In the first few weeks, I'm guiding you to write down everything like this. Okay. Okay. Now raise your hand who got 10 out of 10. Let's see. I want to know who got 10 out of 10. Anuhas, Afsa, Elindu, Arosha, Azma, Yasasi. Right. Now, how many people are in the session now? 58. Now, 1, 2, 3, 4, 5, 6. I don't know whether some of you got 10 out of 10 and not raising hand. So according to the students, those who raised, only there are 6. Let's assume that less than 10. Students tell me, now listen to this one very carefully. Yeah? Now this is the point I want to tell you. Haven't we learned these things before? The theories that we discuss here, haven't we learned? We have learned, right? We have perfectly discussed all the theories. Now, when we are giving, now just I gave you 10 questions, right? Out of these 10 questions, now if you have done these questions, just imagine we should get 10 out of 10. Right? If we have learned the theories properly, we should be able to get the answers 10 out of 10. So I think we learn properly, right? We learn the theories properly. What you are saying, we attend for the classes daily. We learn, we made short notes, we studied, right? Likewise, you are telling now, you can argue with, yeah, that's okay, that's obvious. I know that one. But remember, students, when we go for the questions, that is difference. Now, this is the first impression, this is the first experience. Hereafter, you will understand. When you face for the first term examination, you will understand what is the exam. Now you can understand why we should attend for the paper class. Why we have to follow a paper class for any subject. I don't have to explain that one hereafter. Okay. Yes, Hazika, it's okay, fine. Whatever your marks, it's okay, fine. Next time you have to improve. Huh? Now just imagine you got 5 marks. Next time you have to improve that one into 7 or 8. Okay. Finally, you have to get 10 out of 10. Mark, you want a first target. What is the first target that you have to set? The first target that you have to set is 10 out of 10. පළවෙනි MCQ 10 මොන જાතියාවක්. Definitely I'm going to hit correct answers whatever happen. අන්න ඒ target එක set කරගන්න. Right? Whatever the first 10 MCQs they are giving, I'm going to hit the first 10 MCQs correctly. No one can stop me. So likewise, determine. Definitely you can do that. Okay. පොඩි targets වලට වැඩ කරන්න පුරුදු වෙන්න, right? First of all, practice for the small targets. Then only you can achieve big targets. I think, yeah, video is not that much clear. Yes, glitching or something else. Tejashwin, 9 is a good mark, okay? Narisha, 8 is also a good mark. If you can get 7, 8, 9 also, good mark, okay? So raise your hand who got more than 7 or 7 more than 7. Raise your hand who got 7 or more than 7. There are many people. Okay, very good. Huh? Good, good. Yes. I'm not telling that is bad. Huh? 7 more than 7 is good. But my expectation is actually 10. 10 out of 10. Okay. So how about my physical class students? For the Kavindu, Nibbuta, Eshani, Elindu, then Safna, Janidu, and our Kaviru. What about your marks? Okay. Hmm. Okay, good, good, good. Right. Hmm, hmm. Right, okay. Good, huh? Good. Not bad. What I'm telling you to is improve, huh? Improve day by day. Right. So let's go for the question number 11. Question number 11 is a calculation. So this is a simple calculation. You can go for the answer. First of all, so I want to know what is your answer. So can you put your answers in the chat box for the question number 11? Hmm. Okay. Hmm. Right, right, right. Okay, okay, okay. Right. Let's see. This question is very easy. Now look at this one. A compound which contains carbon and hydrogen only is known as a hydrocarbon. In a certain hydrocarbon, the mass percentage is about, mass percentage of hydrogen is about 12%. The relative molecular mass of that compound is 100. The accurate relative molecular mass of that hydrocarbon is. Now, this is very interesting. Huh? I don't know what is the method you follow. Let's see. Hydrogen percentage they have given as 12%. Then students, what is the carbon percentage? Carbon percentage is 88% for sure. That is for 88% sure. Now look at this one. They have given that relative molecular mass of the compound is 100. Now we have hydrocarbon CXHY. So the relative molecular mass of this compound is 100. That means molar mass is 100 grams per mole. Right? Let's consider relative molecular mass 100. Okay. So can't we tell directly hydrogen? How many hydrogen atoms are there? Now just imagine mass. What is the atomic mass of hydrogen atom? Relative atomic mass of hydrogen atom. Relative atomic mass of hydrogen is 1. Just 1. They have given that mass of hydrogen as a percentage 12. That means when we consider 100, that is 12. Mass of hydrogen is 12. You think students, they have given that molecular mass also 100. Very easy. Then you can tell that hydrogen atoms are what? Hydrogen atoms are 12. We can say that hydrogen atoms are 12. Neither, right? You can say that me mass percentage of hydrogen is 12, carbon mass percentage is 88, carbon hydrogen mass percentage is 12. relative molecular mass of the compound is 100, then the mass of hydrogen is also 12. 12% නේ. එතකොට 100 කියලා කියන්නේ මෙතන 100 අරගෙන තියෙනවා, right? They have taken that molecular mass is 100. Then the mass of hydrogen is 12. One hydrogen atom's mass is 1 relative atomic mass. Then there are 12 hydrogens. Are we done? Are we clear? Then what is the total molecular mass? 100. Then students, can't we obtain the carbon atoms? How many carbon atoms are approximately? We know that if the relative molecular mass is 100, there are 12 hydrogen atoms, then the mass of the 12 hydrogen atoms are 12, then 100 minus 12 is the mass of carbon. Again, in order to obtain the carbon atoms, number of carbon atoms, you have to divide the total mass by the mass of one carbon atom. Relative atomic mass of carbon is 12. Neither 12. Then 100 minus 12 is 88 divided by 12. What is the answer? 88 divided by 12. We can say this is 84. For 40, we can say 3, 36. Again 4, 7.333, likewise repeating. That means 7.333, repeat. Approximately, we can say that carbon atoms are what? Carbon atoms are 7. Carbon atoms are 7, right? But remember, students, I feel like 7.3. Again, 7.3 කියන එක 7 කියලා ගන්න මට හිත දෙන්නේ නැහැ, right? I don't feel like that. I can take that carbon atoms as 7 because 88 is the mass of carbon atoms, right? I have taken, they have given that. Wait, one more thing. Now look at the term about 12%, right? Percentage. Look at the statement they have given. In a certain hydrocarbon, the mass percentage of hydrogen is about 12%. About 12%. It is not exactly 12%. Huh? It's not exactly 12%. It is about 12% volume, right? So, what do you think? These 12% means it's not a correct value, not accurate value. So, 100 minus 12, 88, we are getting 88. So, therefore, students, we can't get the exact value for the carbon's mass as well. Try to understand. That's why we are obtaining 7.3. We can't take that carbon atoms are 7.3. We have to consider that carbon atoms are 7. Neither 7.3 means when we round off that one to the first decimal value, we can say that is 7. That means there are 7 carbon atoms. Minimum there are 7 carbon atoms. Then 12 into 7 is 84. Now we can say that. Now we can say what is the molar mass of the compound. Relative molecular mass of the compound. Exact molecular mass of the compound is what? There are 7 hydrogens, 7 carbon atoms. That means 12 into 7. There are 12 hydrogens. So the summation is 84. 84 plus 12 is 96. 96. Okay. But remember, students, here I'm going for a second option also. Right? Remember, students, since they have given about 12%, it's not exactly 12, right? So that means, what about if I take that hydrogen atoms are 14? That means right? What about if I take they have given that the accurate relative molecular mass of that hydrocarbon. So we can go for the answer like 98 also. It doesn't matter, right? Because since it is about 12%, they haven't given the accurate value. So therefore, if you want, you can adjust hydrogen atoms in 2 more. That means you can change that one into 12 to 14 also. It doesn't matter. So therefore, we can give the marks for 98 also. But the correct answer is 96. Okay. But if someone has put 98, we can give the marks for 98 as well. So in that way, we can consider 100 also. Right? Right? 12% about 12% means that should be near to 96. So therefore 96 or 98 can be taken. For the 100, we can't give marks. Anyhow, carbon atoms are 7. We got the answer 7.3, but we can't take point values 7. Then the hydrogen atoms are 12, 96. Since they have given about 12%, if you want, you can take the answer as 90. So question number 11, I have given you two options. Number 1, number 2, both are correct. Right? අර ඒ වගේ ටිකක් හිතන්න පැතිත් තියෙනවා ගණන් වල, right? Normally you have to think a lot. Raise your hand who got the correct answer for question number 11. So then can we take hydrogen as 10%? We can take hydrogen as 10%, doesn't matter. Then you have to choose another option, 94. Okay? Better you go with only two options. 96 and 98 is enough. Huh? Right, okay, good. Good. So that's a calculation. That is a very simple calculation, but we have to think a bit. Quickly complete this one. Right, okay. Are we done? Shall we move to the question number 12? Question number 12. Students, that is a statement type of a question. Which of the following is not a property of cathode rays? Number 1, when an electric field, first of all, put the answers in the chat box, because this question is very, very easy. Cathode ray theories, everyone should get the answer. Okay. So if you can't get the answer, that's a shame. Okay. That's very easy. What is the answer for this one? Yes. Third one is the answer. Very good. Let's go one by one quickly. When an electric field is applied in path of them, they attract to the positively charged plate. Students, we know that cathode rays are negatively charged. Okay? Cathode rays are negatively charged. They are negatively charged plate, negatively charged particles. When we keep an electric field, you know that J.J. Thomson conducted few experiments, right? under the one of the experiments he conducted, right? We learned that cathode rays are deflecting towards the positivity, right? So they are negatively charged. Experiments were conducted by J.J. Thomson, right? Cathode rays can be converted, can be considered as electrons, because electrons are similar to cathode rays or beta rays. Okay. Likewise, theories we learned. So therefore, that statement is not a property of cathode rays. The first statement is correct. Second statement, for the cathode rays obtained from a different gases, E of M ratio is constant. Is that correct? Yes. Whatever the metal we are using, cathode or anode, or whatever the gases we are using inside the cathode ray tube, E of M ratio value is same. Can you remember E of M ratio value? What is the value? What is the E of M ratio value? 1 point. Can anyone tell me? What is the E of M ratio value? 1.759, 10 to the power 11 coulombs per kilogram, minus 11, right? The next statement they have given is it deflects towards the north pole at a magnetic field. What do you think? Is that correct? In a magnetic field, students, what will happen? Hmm? In a magnetic field, we know that there is no deflection, right? There is no deflection. This one should be plus, okay? Plus level. Okay. In magnetic field, Right. Okay. Students, can you hear me now? Can you hear me now? Right. Okay. Good. So, what I was talking about is actually if you want to write down reviews, you can write down for some questions. Remember, students, for some questions, you can skip the reviews, right? Now, if you can remember these simple theory parts for the cathode rays and everything, no need to write down that one, okay? So that is decided by you. You have to decide that one, okay? Whether you are writing that one or not. For calculations kind of questions, definitely you have to write down reviews, okay? So that's what I told. Question number 13, the maximum number of electrons possible in the sub-energy level given by L equal 3, right? Now let's go for the quantum numbers theories quickly. Let's revise the theory part we learned for the quantum numbers. So can you remember quantum number theories? So quantum numbers are representing the location of electrons. We can track the electrons. We can trace the electrons using quantum numbers. So tell me, what are the four types of quantum numbers we have? N, L, ML, MS. Quickly. So what is N? N means principal quantum number. So the principal quantum number is representing the principal energy level, right? N equal 1, 2, 3. Likewise, we are representing the principal energy level. And what does mean by L? L means angular momentum quantum number or azimuthal quantum number. It is representing the sub energy level. For an example, L equals 0 means we can tell that is S sub energy level. L equal 1 means P sub energy. L equal 2 means D sub energy. Likewise. And what about the third one? Third one is the magnetic quantum number. Students, magnetic quantum number is representing the orbital type. We know that in the sub energy level, there is one orbital. So therefore, we are giving a number for that one as 0. In the p sub energy level, we know that there are 3 orbitals. So -1, 0, +1. So likewise, we are giving a range of values for the orbitals. When you go for the d sub energy level, we know that there are 5 orbitals, -2 to +2. -2, -1, 0, +1, +2. Likewise, orbitals are there, right? Likewise, we can give the numbers for the magnetic quantum numbers in this way by depending on the orbitals. Then what about this one? MS. MS means spin quantum number. Spin quantum number. So spin quantum number is representing the rotation of electron, right? It can be either clockwise or counterclockwise, right? We can assign the values like +½ or -½ right? We can exchange them, no issue. So we can say that clockwise direction and the counterclockwise direction, right? Clockwise and counterclockwise. So remember that we have 4 types of quantum numbers: principal quantum numbers, angular momentum, angular momentum. If not, we can say that azimuthal quantum number, azimuthal. Then we have magnetic quantum number. At last, we have spin quantum number, right? Spin quantum. Now go for the question. The maximum number of electrons possible in the sub-energy level given by L equal 3. Students, L means angular momentum quantum number representing the sub-energy level. L equal 3 means which sub-energy level is that? L equal 3 means which sub-energy level is that? That is F sub-energy level. In S sub-energy level, we have 1 orbital. In the P sub-energy level, 3. In the D sub-energy level, there are 5. Then tell me in F sub-energy level, how many orbitals are there? How many orbitals are there in the F sub-energy level? 7. 7 means there are 14 electrons. Question number 13, answer is number 5. Quickly write down this. Quickly write down. So in past paper, I see questions where they ask the highest or lowest ionization law penetrating effect. Can you please say the order of the increasing ionization and the alpha beta gamma? Yeah, that's easy. Remember, when we consider the penetrating power, right? Remember, Najma, penetrating power, the order is increasing order is alpha beta gamma. That means alpha beta gamma gamma particles have the greatest penetrating power. Then when we consider ionizing power is gamma, beta, alpha. Alpha has the greatest power, ionizing power. Okay, got the answer, Najma? Right. Okay, students. Right. So this is what I wanted to discuss with you today. Uh, right. Now listen to this one very carefully. Now the question discussion is over. First of all, please raise your hand quickly who understood the things that we discussed today. Quickly raise your hand. If you have any doubts, put your doubts in the chat box. Raise your hand quickly who understood the things. If you have any doubts, put your doubts in the chat box. Right. Okay, good. Now this is the plan. Yeah, Anuhas, those things will be informed by the academy, online academy class coordinator. She will send you a message, okay, about those things. Now listen to this one. Students, the plan is every Monday we are conducting this paper class 8 to 10:30, right? So let me tell you like this: 8 to 10:30 means not exactly 10:30. So since this is the first day, I'm going to wind up the class till exactly at 10:30. Sometimes in the next week onwards, 10:40, 10:45, 11, maximum 11. Okay, just imagine 3 hour classes. Okay, so and the next thing is now today we discuss only 12 MCQs, right? So actually that is not enough for me. For me, that is not enough because I discuss so many things. Little by little, day by day, we are going to increase the speed of the paper class, right? Even in the theory class also, we have to speed the theories. Okay, little by little, not suddenly. I'm going to reduce the discussion little, and you have to write more. You have to think. And when you have any doubts, you can put the doubts in the chat box, and we can discuss these things. Okay, and remember, when we when we are doing a paper, time is also very important, right? So when you come to the next paper class, you can try the next MCQs. Next 3 MCQs are there, another 13 MCQs are there, and you can try the structured essay question also. If you want to keep the time and do, put 15 minutes for each structured essay question and do, right? I will give you the marks also. For one structured essay question, we are allocating 100 marks. Out of 100, how much you can get, right? If we have time next week, we are going to go for the structured essay papers also in the paper. Okay, right. Okay, so I believe that anything else, any doubts? Right. I believe that you don't have any doubts here then. Right. Okay. Then I need a small feedback, okay, from you. So is this effective? What do you think about the paper class? Very amount, very case. Tell me something. මොනහරි කියන්න right? නිදිමතේ ඉන්නේ කට්ටිය. Okay, right. Nari bad comments තියෙනවා ඒත් අවුල නැහැ, right? Negative reviews also acceptable. It's fine. Right. Okay. Okay. Good. Good. Okay. Thank you. Right. So put a small review in the WhatsApp group also. Okay. Don't send me personally. Directly that one to advert one and that one to the WhatsApp group. Okay. So you will get the recordings soon after the class, after today's class. Then let's meet on the Thursday theory class, Thursday night, 8 p.m. to 11 p.m. We have to do structure and memory. Okay. So study hard, work hard, ready for the examination, get ready for the examination. So let's meet on Thursday night. Until then, bye bye. Have fun. Good night, all of you.